linear functions. Alright, so linear functions are the same as linear equations, but they are written with what's called function notation. Okay, and that's pretty simple. Okay, function notation is just something we use in place of y, and we write it as f and parentheses x. Okay, and this is pronounced as f of x. Okay, and that just stands for the function of x. Okay, the function where x is my independent variable. All right. So if I have an expression y equals 2x plus 1, I can write that as a, and this is a linear equation, I can write it as a linear function by using function notation to replace my y. F of x equals 2x plus 1. Okay? Same thing, really. But this is a linear function, this is a linear equation. Okay, there is a difference. Usually they're basically the same, but there is a slight difference which we will get into later on. Okay. However, one thing to note is if you ever have a variable other than x here, this will be the same. Okay, these will be the same, and this is not f times x. Okay, this isn't a mathematical expression, this is a symbol, f of x. All right. Okay, so our first concept is identifying linear functions. All right, and we identify them the same way we identify linear equations. Okay, except that we're also looking for function notation. All right, so this has function notation, and it's expressed in slope-intercept form. So I have f of x equals mx plus b. All right, so that tells me that this is linear. So this is a linear function. All right, so this will look pretty similar or pretty familiar because we did look at what was linear and what was nonlinear before. So linear functions, this is a linear function. Doesn't matter if it's plus or minus my y-intercept. I have f of x is equal to a number times x plus or minus another number. Same thing here, even though I don't have a number next to x, still a linear function. Okay, here I'm basically adding 0, right? I don't have a y-intercept. It's still a linear function because I have a number times x, and I don't have any squares, any exponents, any square roots. I'm not dividing by my variable or anything weird like that. Okay. Now we're getting into something that's sometimes a little bit harder to see, right? Because this doesn't really look like my mx plus b. All right. But if we're given this, we need to try and simplify it. We need to try and convert it into slope-intercept form, which hopefully you are pretty familiar with at this point. So I have a minus 3, but my goal is to have my function notation by itself, just like I used to try and have my y by itself. So to move that away, I add 3, add 3, and I would get f of x is equal, since those cancel, to 2x plus 3, and this is a linear function. We can see f of x equals mx plus b, where m is 2 and b is 3. Okay. Same thing for this one, except I don't have to move anything to the other side. I just have to combine like terms. I have a positive 3x and I have a negative 4x. So 3x minus 4x gives me f of x is equal to a negative 1x, and then I still got my plus 2. And again, a linear function. Okay. Once again, these are the most common, although not all of the non-linear functions. Okay, anything with an exponent, that's probably the most common. If you're ever dividing by the variable, so your variable is on the bottom, that's not going to be linear. A square root of your variable is not linear. If you're multiplying your f of x times x, that's not linear. That's the same as the old y times x, and that wasn't linear either. Okay, so anything like this will give you a non-linear function. All right, and that is all.